Homework number 19. Questions 1 through 5 ask you to solve for x by showing all of your steps. So for question number 1, I see that the right-hand side of my equation here has 3 different terms. 2 of these terms share the same variable. So these are like terms that can be combined. I'm going to leave everything the same on the left side, but on the right side I'm going to combine 6x and 2x to make 8x minus 20. Now, you might notice already that we have similar x variable terms, but they are not the same. And if they're not the same, then we have to keep computing all of our inverse operations until we isolate the letter x and get all the constants on the other side. In this case, the constants will move to the right, and the variable term will stay on the left. Sometimes when you divide, you do not get a whole number, and when that's the case, you can reduce your fraction, or you can convert it to a decimal. Let's take a look here. If I have negative 24 divided by negative 16, it's a pretty good looking decimal. So we could write that as positive 1.5. Otherwise, if we want to leave it in fraction form, I can use my calculator here in fraction form to reduce my fraction and get 3/2. So you could write 1.5, or you could write the fraction 3/2. Let's take a look at question number 2. I'm going to add 5 to both sides, leaving me with x divided by 3 is equal to 3. Now, this is division, and the inverse of division is multiplication. So I'm going to multiply both the left and the right side by 3, leaving me with x equals 9. Question number 3 needs some distributing here. So I'm going to get 3.6x plus whatever 3.6 times 4 is. So I'm going to use my calculator, 14.4. Now my coefficients are not the same, and this side of my sentence only has one term. So I don't want to add 3.6x to both sides here, because then there would be nothing left. So what I'm going to do here is I'm going to subtract 3.6x from the left and the right, which will leave me with an x on the right-hand side. 7.2x. And now I'm going to divide both sides by negative 7.2, and that leaves me with negative 2. All right, let's take a look at the next 2 questions. Number 4 asks us what the solution is for x cubed. So some number times itself 3 times is 216. And the inverse of an exponent is a root, which looks like that. So we're going to use our calculator to compute the third root since we have a power of 3. These are inverses. And whatever you do to the left side, you have to do to the right side. So I'm going to use my calculator to compute the third root. Now for most of you, you'll have a symbol that looks like this, but has a number in front of it. So I'm going to see it here with this special calculator, but you need to put a 3 in front of that square root sign, that radical sign, but in the index position. And I'm going to type 213, and there we go. That means x is equal to 6. So this is what it means when it says show your inverse steps. All right, number 5, negative 8 minus 5x is equal to 20. So I'm going to add 8 to both sides. And then I'm going to get negative 5x equals 28. And I'm going to divide by negative 5. And again, I can convert it to a decimal, or I can leave it in fraction form. If you have a fraction button on your calculator, you can type it in fraction form and it will reduce it for you. So there is no common factor, so you could leave it as 28 divided by -5, or you can use the division button here, right? This key right here, division by -5, and you can get -5.6. Either answer is acceptable. This or that. The next section asks you to determine the sequence of transformations that maps A onto A prime, or ABC onto A prime, B prime, C prime. So I have an extra question here that asks you to prove how you chose your multiple choice answer. And how you're going to do it is you're going to choose an initial point, any point you like, so I'll pick A, and A is the coordinate 4, -4. And what I want to do is get it over to A prime. A prime is located at -4, -2. So I can see that the point here has translated. I can see that because the numbers are different. So to go from -4 to -2 means I would have had to add 2. Now I also notice that this 4 and this 4 have different signs. And the only way that a number can change signs is by a reflection. And when you reflect, the coordinate that changes is not the axis you reflect over. So if I want to change the x coordinate, that means I need to reflect over the y-axis. So a reflection over the y-axis is what happened. And when I reflect over y, I'm going to get -4 and -4. And now I can bring back that translation of moving 2 up. Right, so I said I had to do +2, and since we are changing the y value, that means that we are going up or down. Question number 7 asks you which represents a linear association between y and x. Which table best represents a linear association? And linear means to be almost like a line. So you'll notice A is a bit curved, E is all over the place, C is also curved, but D is mostly like a line. So D is the best linear association. Number 8 asks you to dilate a figure using a scale factor of 2. And when you dilate, you multiply the original coordinate by the scale factor. And if we are dilating by a factor of 2, that means I multiply each coordinate by 2, giving me -4 and a 6. Question number 9 asks you to rotate it 90 degrees counterclockwise. Well, everybody knows a 90-degree rotation takes your axes, right? Takes your x and y axes, and it switches them, right? So when I group these together and I start to rotate it, you'll notice my blue y-axis, 90 degrees, becomes my x-axis. So we know that we have to swap the position of each of these coordinates. So my y will go first, and my x will go second. And then if you draw an arrow in the direction of which you're turning, counterclockwise, it will point to the coordinate that needs to change signs. So the answer is +3, +5. Question number 10 asks you to determine which equation would pass through the line with an x-intercept of 9, 0, and a y-intercept of 0, -5. Well, we can notice here that all of these are written in slope-intercept form, so if I knew the slope, I could probably figure out my equation. Remember this slope formula here? That's what you're going to use. So we make our giant subtraction fraction, and we do y minus y over x minus x. So my slope is -5 over -9, or positive 5/9. And there's only one equation here that has a slope of positive 5/9. And that's letter D. Question number 11 asks you to describe a sequence that maps xyz onto x prime, y prime, z prime. So let's pick a coordinate, x, which is located at -10, 2, and let's find out where it lands at the end. X prime is located at -7, -4. So it looks like we definitely have a translation because our numbers are completely different. But I also see that y was on top and now y is on bottom. That's a big hint that I'm likely reflecting over this x-axis. So I know that a reflection over the x-axis took place, and that would give me an x value, that used to be 2 units up, and it will now be 2 units down, so right here. So the original move will put us at -10, -2. Now, how do I get from -10 to -7? Well, I have an increase or a translation, a slide of 3 units to the right. And then how does -2 become -4? 2 units down. So 1, 2 units down, 1, 2, 3 units right. That puts us here. And that concludes homework number 19.